How hard is it to keep rocket fuel in space? Which is better, a lunar base on the surface or in orbit? How would a space station look like in a binary planet system? And in Q&A Plus, could we launch a probe into a black hole? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Gio Hondo, is it problematic to keep rocket fuel in space for extended time? I hear hydrogen escapes no matter what, but I don't know if that's true. Yeah, this is one of the biggest problems with space refueling. So this idea of space refueling, like up until this point, rockets have to carry all of the fuel on board for their entire mission. And when you think about something like, say, New Horizons that launched from the Earth, flew past Jupiter, did a flyby of Pluto, flew past Arakoth, another Kuiper Belt object, and still has a little bit of fuel in the tank to probably see another target, it had to carry all of that fuel in all of its stages. And it doesn't even have an ion engine. It had to use a regular old chemical propulsion system to make that journey. Everything else, right, is just you put the fuel on the rocket, you launch it into space, it completes its mission. And even when you go back to the Apollo missions, right, you had Saturn V, you had the 3 propulsion stages, you had the command module, the landing module. Each one of these little modules had its own little fuel tank and its own little rocket to be able to allow it to complete its mission. And one of the big ideas that several of the aerospace companies have been suggesting, and the big company for this actually has been Lockheed Martin. Back in the late 90s, early 2000s, they were starting to pitch this idea of fuel depots in space. And the idea is really elegant, right? That if you are able to launch your spacecraft into space, it doesn't have to be that big if you aren't going to be carrying very much of your fuel. And if you're going to be carrying people, it can be a very safe rocket, something that's designed 100% to just carry humans to space safely. And then you can refuel at one of these fuel depots. Now, today, you're going to have to launch rockets that will refuel the fuel depot, which will be a different thing. But they can be sort of more cargo spacecraft. They don't have to be as safe as the ones that are for carrying people. And then your human mission to the moon or to Mars or whatever goes into space, goes to this fuel depot, replenishes its fuel, and then it can carry on its entire mission. And you've got all of that capacity for fuel, the fuel capacity that you use to just get into orbit. You can now fill it all back up again and pretty much go anywhere in the solar system with that fuel. And then, of course, the other mission that you've probably heard a lot about is the SpaceX Starship, the human landing system, but just like in general, SpaceX has been thinking about how you can do orbital refueling. And a lot of their long-term ideas really depend on orbital refueling. If you want to send humans to Mars, you launch this thing, it uses up all its fuel to get into orbit and then meets with the fuel depot, replenishes its fuel, or you have other starships filled with fuel that meet up with it, replenish its fuel, you fill its fuel tanks, and now you've got a spaceship that is completely filled with fuel and you can easily make your journey to Mars. So the idea is very elegant. And in the far future, once we have, say, mining water off of the surface of the moon, or once we have asteroid mining, then the fuel depot makes a ton of sense, because then you're not having to bring up that fuel from the surface of the Earth. You're bringing that fuel from some other location out in space where you haven't had to get out of Earth's awful gravity well. The idea makes a ton of sense, and it is absolutely, inevitably our future. But the challenge is that cryogenic propellant systems like liquid hydrogen, liquid oxygen, or even liquid methane, these are tricksy and can escape. And that there's a lot of other technical challenges you have to deal with when you're in weightlessness, the fuel is floating around inside your tank. And so you have to use pressure to be able to kind of push the fuel in a certain direction. There's various solutions to be able to solve this problem. But as you said in your question, it's hydrogen that is the worst. And that is probably the most useful propellant component, that you're going to mine water, you're going to break it into hydrogen and oxygen, you're going to store the hydrogen under a compressed liquid form in your fuel depot. But the atoms of hydrogen are so small, the molecules if it's H2, but hydrogen is so small that it's able to get out of almost every kind of containment. And when you're out in space, your fuel depot is going to be going through cycles where it's going to be getting heated and cooled if it's in orbit around the Earth and it's going to the shadow of the Earth. And so all of the metal is going to be expanding and contracting. And you've got to be able to come up with a fuel storage system that can handle that. So people are working on solutions both for the storage of cryogenic fuel as well as transferring cryogenic fuel. There have been test experiments installed on the International Space Station. The Chinese just recently, in the last couple of months, tested out a refueling spacecraft that would try to deliver fuel. In this case, it just delivered fuel to itself, but it, in the future, you'll see that. We have seen servicing spacecraft that have been launched and have docked with target spacecraft. But right now, the only really official plan is what SpaceX is going to be doing, and not even a fuel depot. So they're going to be launching the human landing system into orbit, and then they're going to launch other starships that are going to have to dock with the human landing system and transfer propellant to it, and then it's going to travel out to the moon and bring the astronauts to and from the surface of the moon. So this is the dream for long-term reusability space exploration, but there are a lot of technical challenges. And I always sort of use this as one example of why space exploration is going to be so hard, and that there are all these little tricky things that we have to work out. How do the astronauts eat? How do they drink? How do they breathe? How do they go to the bathroom? What do we do? What do we do with waste? How do we deal with the medical issues? Long-term space exploration is going to be very challenging. And yet, if we can overcome this, it'll bring out the best of us. So let's do it. It's time to shout out all the new $5 patrons and above: Dave Bundy, David Borries, Daryl Griffiths, Sigurd, Chris Richardson, Astrophysics, Mark Shores, Ashok, Flightpath 35, and Michael Prude. Join the club at patreon.com/universe today. Drew D2, would a lunar base or space base be more effective for reducing the cost of space exploration? It really just depends on our level of infrastructure. So when you think about a space base, like say we've got a space station that's orbiting around the Earth, and we have spaceships coming and going from the space station, and then the space station has refueling capability, and then people go off into space. And instead of putting it in low Earth orbit, why don't we put it at the Earth Moon L1 Lagrange point, which is this balancing point gravitationally between the Earth and the moon. And so once you're at that point, then you can head off into the solar system, and you no longer have to escape a lot of the Earth and the moon's gravity. Or if you go to the L2 point, which is on the far side of the moon, now you're like right at the very edge of being captured by the Earth and the moon, and it takes very little propellant for you to then head off into space. So if you put your station down on the surface of the moon, then if you want to leave the moon, you're still going to have to fight the moon's gravity before you head off into space. So that's the downside. But the upside is you have access to solid ground, stuff that you can mine off of the surface of the moon. You had access to the permanently shadowed craters on the moon that you can supply water and so on. And when you think about 2001, they ran their mission off of the surface of the moon, which was pretty cool. And they went off to, was it Europa? Where did they go? Jupiter? Yeah, from there. And so you could imagine one possible future is that we have a base on the moon that is people are able to then launch off the moon. You have to pay to get out of the gravity well of the moon, but it is less than trying to get off the gravity well of the Earth. And the other possibility is that we will have this base out at the L2 Lagrange point, and that will be the waypoint, the true gateway to the rest of the solar system. And eventually both will be there. Both will make a ton of sense, and we will maintain them and use them as ways to get out to the rest of the solar system. That they will be fuel depots, they will be hotels, there will be logistics hubs, communications hubs, and they will provide, and general stores that will provide people what they need before they head off into deep space. Visto Tutti, are we capable of launching Voyager-class probes out of our solar system today? For sure. The most recent spacecraft that was sent on an escape trajectory was New Horizons. And New Horizons did a flyby of Jupiter, but it didn't do a flyby of Saturn or Uranus or Neptune, and it is on an escape velocity. It's not going as fast as the Voyagers were, and so it's never going to catch up. It's moving in a different direction for the Voyagers, but it will never catch up in distance to the Voyagers. They are always moving a little bit faster than New Horizons, but still, we have the capability to send an interstellar mission without having this grand alignment of the planets. But that was amazing. When you think about the fact that you could send one mission to do the grand tour, to go past Jupiter, Saturn, Uranus, Neptune, and give us close-up images of all of those for the first time in human history, that you got to see Uranus and Neptune up close. Absolutely amazing. Now we have to send missions to those worlds on their own because they're not lined up, and you can't do gravitational assists to line them up again. We won't be able to do that again for 150 years or something like that. So we have to do this the hard way. But NASA is working on a mission called the Interstellar Mission. And so this would be to send a mission rapidly out into interstellar space, out beyond, say, the Kuiper Belt, out into a region where you're really experiencing the combined solar winds from all of the other stars that are out there. The kinds of observations that the Voyagers are making as they just run out of power with instruments that were never really designed to do this job. What if you could do a much better understanding of how the sun interacts with the rest of the stars in the Milky Way? And so we can see future missions going on escape trajectories, at some point in the coming years. And of course, if you want to go to the solar gravitational lens, that is, 550 astronomical units from the sun. If you want to do that in a human lifetime, you got to go fast, which means you're going to be on an escape trajectory. So any mission sent to the solar gravitational lens will be on escape trajectories. In fact, people are still proposing that we could do missions to do flybys of Oumuamua, Borisov, 3I Atlas even. But if you took a Falcon Heavy, stripped it down, did a bunch of gravitational assists, you could catch up with Oumuamua in 50 years. So we still have the ability to provide close-up images of even some of the interstellar objects that have come through the solar system if we have the will, which we don't. The Light Runner. If we lived on a binary planet system and built a large space station at the barycentre, would it be 0G in the middle of it? Yeah. So I'll give you sort of an analogy, which is imagine going inside the Earth. So if you went down to the middle of the Earth, you would be weightless because you would be pulled at equally in all directions from the mass of the Earth. You would be floating around. In fact, if we dug a hole through the Earth all the way through out to the other side and you jumped into the hole and there was no friction and there was no air and you fell down, you would accelerate as you are going towards the center of the Earth. And then you would experience this weightlessness as you got closer and closer to the center of the Earth. And then your momentum would carry you all the way up the other side to, your eyes would peek out of the other end of the hole, and then you would fall back down and just oscillate back and forth. And so if you had a binary planet system, an ideal binary planet system, which is impossible, which we'll get into in a second, you had two planets that were orbiting around each other, then if you were positioned right in the middle of those two planets orbiting around each other, you would experience weightlessness. And the space station would require the minimum amount of fuel to be able to maintain that position. And you sort of imagine it it's like a Lagrange point, that you are at the top of this gravitationally unstable point. It requires very little fuel to remain at the top of that point. But once you start to drift away, then you can imagine you start to drift closer to one of the planets or the other. You start to accelerate towards that planet, and then things go haywire. But that is the sort of idealized platonic version of that. But the reality, of course, is that the planets aren't going to be the same mass. You're going to have the influence of the star, the influence of other planets, that you are going to be perturbed just by all of these gravitational interactions. And it doesn't take much for oscillations to set in and for you to start to end up in a sort of chaotic orbit between the barycenter of these two objects, and you will eventually crash into one or be kicked out of orbit or whatever. And it's that same thought process you should use to imagine the unstable Lagrange points. When you think about L1, 2, and 3, which are lined up between the star and the planet, that those 3 points are gravitationally unstable. You can hover in that region with a minimum amount of fuel, but once you start to drift away from that idealized position, then you will sort of fall out of that gravitational well. And there's no perfect place you can be because there's always the interaction between the other bodies in the solar system. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And we call it Q&A Plus. And this week's bonus question, could we launch a probe into a black hole? I'll put a link in the show notes. All right, those were all the questions that we had this episode. Thank you everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. We record that every Monday at 5 p.m. Pacific time. So if you want to join us for the next live show, and then there's going to be a break for a couple of weeks. So definitely come and join us. I'm going to respond to a comment about why astronomers are trying to disprove God. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bielak, Dark Finga, David Giltonen, David Matz, Eric Lindstrom, Evan.pro, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Suntz, Michael Purcell, Nordspace, OneStarForAnimals.org. Please follow my nephew at VBrick6994, Ring Kaidu, Richard Williams, Sean Sargent, Stephen Farley Munley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I got this question, and I get this kind of question quite a bit, so I'm going to sort of interpret it a little more wider than I think was asked. General Cirque. So they want to waste billions more on a new telescope to try and disprove God. James Webb shattered the Big Bang Theory. Maybe we should spend this money on, I don't know, beating China to the moon, or maybe building new nuclear reactors for clean, cheap energy. I mean, almost anything would be better than another space telescope at this point. So I get this question quite a bit, and I think there's sort of like two versions of this question. So I'm going to tackle the why are astronomers trying to disprove God part first, and then I'll tackle the why are they spending money on stupid research part second. So first, why are astronomers trying to disprove God? They're not. They're not trying to prove or disprove God. All astronomers are doing is using their telescope, looking out into space, and describing and trying to understand what they see. And there is this natural limit to how far astronomers can see, which is about 340,000 years after the Big Bang. And this idea that astronomers are trying to disprove God does not come from astronomers. It does not come from scientists. You ask a scientist, even like an evolutionary biologist, why are you trying to disprove God? They're like, what? You ask an astronomer, why are you trying to disprove God? They have no idea what you're talking about. This is a talking point from people who are religious, because the evidence that astronomers and scientists are discovering about the universe does not necessarily line up with some readings of religious texts. That should not be surprising, especially when often religious texts will disagree with each other about their creation myths or whatever. And obviously, if you have sort of locked down your worldview to a very specific interpretation of a book that was written several thousand years ago before modern technology. You know, if you were a believer of Greek myths and you believed that Zeus was up on top of his mountain hurling lightning bolts down, and now we understand how lightning bolts work, then you might see this as an assault on your proof of Zeus. Right? Your belief in Zeus. If we have a perfectly natural explanation for where lightning bolts come from that don't require Zeus, then if you were an adherent of Zeus's, you're going to feel like this is an attack, but it is not an attack. And that there are plenty of people out there, plenty of religious people who are scientists. And they don't feel any collision between the discoveries they're making about the universe and their personal beliefs about the supernatural. They are perfectly complementary to them. And that this says more about a person who is unwilling to be sort of open-minded about what's out there in the universe and sort of be flexible to change their worldview when new evidence and new information comes in. So no one's trying to disprove anything. They're just trying to examine nature and just tell you what they find. And if you don't like what they find, that's on you. It's not on them. But this question that we always get as well is like, why are people spending money on James Webb or another space telescope or whatever when they could be doing engineering, developing fusion reactors, beating China to the moon, whatever? And the whole point of research, of basic research, of just investigating nature is that we don't know. We are just curious. We don't know where it's going to lead. Now, we live in this modern society where we have all of the technology. We have the internet. We have lasers. We have satellites. We have, I could just go on for 1,000 years describing all of the technologies, the transistors, microchips, radio waves, all of this, right? And these all came from somebody just interrogating nature, someone just going out and going, I wonder how this works. I wonder what is the underlying mechanisms of how this part of the world, the universe works. And then later on, someone says, I bet we could do something with this. We could do some kind of engineering solution or whatever. And it has always been that case, and it will always be that case. And so the things that people are investigating right now, some of them are going to pan out, some of them will be dead ends, and some of them will completely revolutionize what the future of humanity looks like. And we don't know which ones it's going to be. And so we have to just let the process continue. But when I think about how money is being spent, we're looking at tens of billions of dollars being spent to arm and kill people in various wars and conflicts around the world. Let's decrease that and focus instead on getting along, trading, and investigating the world as we find it around ourselves. All right, we'll see you next time.